Hello guys, today I'm gonna talk about engine oiling system. In this first picture you can see on the left typical oil system in your road going car and dry sump oil system on the right. That is maybe a typically racing car used. Right away you can see that we have here many parts that you have to buy, so it is going to be pretty expensive. And because there is not a lot of kits for a lot of cars, you'll have to figure it out on your own, how to connect all the parts and how to manage it. This may be a very demanding task. That's why we will show you our experience with it. So let's look up some reasons why to use it. You will be able to lower your engine mounting point and you will probably get rid of your oil starvation. General oil system problems are oil starvation that you will be easily get rid of with the dry sump system, because dry sump tank is way more better designed than a wet sump. Oil cavitation is a problem that you will probably introduce with dry sump system, because if you put your oil tank in a boot like we did, the supply line from the tank to the pump will be very long, and your pump will have a problem to pick up the oil. I will give you a link on this cavitation phenomena so you can see what it is. Oil overheating will be better managed with the dry sump system. Oil aeration or foaming is where you will get small air bubbles in your oil, and this problem, I don't know, is it better or worse than with wet sump system, but you will have it. You will find many schematics how to connect this dry sump system. On this picture you can see how we connect it, just without this optional cooler. And on a filter you can have sandwich adapter that will have thermostat, and oil will not go through the cooler all the time. We get rid of this thermostat. We tried 3 different ones, and in our opinion this thermostat foams oil, and we do not use it anymore. Now I will show you ACU log of a typical stage taken during the summertime. You can see here intake air temperature is 56 degree of Celsius. All temperatures are in Celsius, and oil pressure is in bar. So outside temperature during the day was around 30 or 33 Celsius degrees. So the intake temperature is pretty high because this car sits for some 5 minutes in the pre-start. And here you can see start of the stage. You see that we start around 5000 RPMs, and the clutch is released, so full throttle acceleration. At the start oil was around 78 degrees Celsius. Water is around, or coolant temperature is around 90 degrees Celsius. And you can see as we drive this stage, you can see that oil temperature rises up to 100, 105, 6 maybe degree of Celsius. And you can see that we are maintaining around 4.4 or 4.5 bar of oil pressure. And you see here that air intake temperature has fall down because the fresh air was coming into the intake. Here you can see that the stage is over, so it's 107 degrees Celsius oil temperature at the peak, and the pressure was maintained at good level. Here you can see our tank. We have bottom door for cleaning. Here is the pickup line. You can see it in there. It has from the bottom a hole. And the first trapdoors. Second trapdoors are here, which are on a head. All the magic of this tank is in the head. You can see here the pouring opening, breathing line, another breathing line, and this is the return of the oil to the tank. Oil tangentially goes into this barrel and swirls. This cone helps to increase the speed of the swirl, which helps with separation air and oil. You can see from inside that you have another barrel in there, and from this middle barrel air and foam goes through this line into the catch can. This goes like that. Obviously we have O-ring here for sealing, and that's it. You can see that we have another cone for swirl, and you can see that this cone has much larger opening diameter, because if you go more and more into the cone, you get better higher and higher speed of the swirl, but when the oil flow is very high, we had problem because this oil seals this, and the oil started to return into the catch can. So we had to make a larger one. You can see here we have oil pump. This oil pump is 3-stage pump. This one is a pickup line, so from the tank oil goes here, and this is the pressure outlet which goes to the engine. Here is the pressure adjusting screw, here you can see, and this pump has 2 scavenge ports. This sucks oil from the oil pan from the engine, so you can see one is sealed and another is the return line which goes up here. These external pumps can have more stages, especially scavenge stages, because some people like to have vacuum in their engine pan. Vacuum helps to produce a little bit more horsepower, because the crank is spinning at a very high speed, and these suction stages, suction oil that comes through this line is full of air, it's like a foam, and goes here. So that's why we have this system to defoam oil. If you want to know more about this cyclone system, you can Google about it. Even vacuum cleaners work on this principle. Here you can see our oil pan with these two suction points. These plugs have magnets, so any metal debris won't be in our pump. This oil pan has a fine mesh inside, so it prevents any kind of damage to get stuck in a pump and ruin our pump. Let's conclude this episode. So, would I recommend this system to anyone? No, I would not. Why? Because it's too expensive and too complicated to make it work as it's supposed to work. Maybe professional racing teams, they have enough engineers that can handle this, but I have read a lot about that, and even in professional racing teams they have problem. So even if there is some system manufacturer claim you that you will have a better oiling system, don't believe them because they sell this. And no, you won't. You will have to work a lot. Maybe we have a little problem that we cannot put oil tank in an engine bay. This would maybe make the system better because the lines would be shorter. I've seen in the Ford Escorts that they use this system as we use it, and they have feeding line N-12, which is probably too small. We have a feeding line with internal diameter of 20 millimeters, which is a little bit bigger. And we have made this cyclone deaeration system, which I believe they don't have. And you will have good pressure, but I don't believe that this is good quality oil that will go into your bearings. So if you want good quality oil, you'll have to work a lot to make it happen. I will give you some tips that we have learned. You have to be careful with sizing your pump. Try to inform yourself as much as possible. You should be careful with some mesh or filters or screening that you put in front of your scavenge ports, because it will foam your oil a lot. Get rid of the thermostats because they will foam your oil also. And be careful with your feed line to the pump, from the tank to the pump. This line is also critical to not get cavitation. If it's short, then it can be in smaller diameter, but if you have a long tube, then you should go with a large diameter, so the pump won't suck the oil from the tank, so the tank can feed it by gravitation. Thank you for watching. Bye.